Hello, everyone, and thank you so much for joining us tonight. My name is Maddie, and I'm going to be your host for this electronic 4-H meeting, actually. So I am a first-year PhD student at the University of Florida studying agricultural communications, and I am here today on behalf of Streaming Science. So a little bit about us. Streaming Science is a college student-driven project that really aims to increase overall science literacy, particularly when we're looking at middle school and high school students and teachers. And now we're actually broadening our reach to focus on some 4-H clubs as well. So thank you all for coming and being a part of this. Today's virtual 4-H club is called From the Ground Up, where we're going to be talking a bit about soil health, different aspects of soil, and also diving into more specifics on certain crops like peanuts. And so we're here today at the North Florida Research and Education Center in Suwannee Valley, and I'm joined by our two experts. So this is Jay Capasso, and this is Kelly Ah. And so Jay, if you want to go ahead and start us off and just tell us a little bit about yourself.
Hey everyone, I'm Jay Capasso. I'm the Row Crop Extension Agent for Columbia County Extension. So I work with farmers in my county, in Columbia County, which is in north central Florida, and I work primarily with watermelon farmers, peanut farmers, and field corn farmers.
Awesome. So now we're going to introduce Kelly here. So Kelly, you can tell them a little bit about yourself now.
Yeah, so my name is Kelly Ah, and I'm the Suwannee River Partnership Outreach Coordinator, and I'm based here at the North Florida Research and Education Center in Suwannee Valley, here based in Live Oak.
Awesome. So you might have heard Jay mention that he is a row crop extension agent. And so Jay, if you want to go ahead and tell us a little bit about what extension is and what as an extension agent you do.
So every single state has a land-grant university where agricultural research occurs. And these land-grant universities hire extension agents like me to get that research, the information that we gather at the University of Florida, especially related to agriculture, but other topics as well, and get that out to our stakeholders, get that out to members of the public. For my extension program, that would be row crop farmers. So if there's new research going on about peanuts, we don't want that new information to stay at the University of Florida. We want it to get out to our peanut farmers so that they can use that new research and be competitive in the agricultural industry and in the market.
Awesome. So I think that the focus of some of our 4-Hers who are going to be joining us here today is to really explore different career options within agriculture. So if someone was interested in becoming an extension agent, what is kind of the path that they might take? If you want to tell us maybe a bit about your experience with schooling, some of the areas that you studied in to get on this path.
Yeah, so for extension agents, you generally need a bachelor's in an agriculturally related field to be hired. Some extension agents focus more on horticulture, some focus more on livestock, some focus more on agronomy and row crops like I do. So my background is I did a bachelor's in international agriculture and rural development, where I got that at Cornell University in upstate New York, which is the land-grant university for the state of New York. And then I moved down here to Florida and got my master's degree. And then that was in soil and water sciences here at the University of Florida. And a few months after graduating from that, I got my job in extension. So there are a lot of different jobs in the agricultural field. If you think about farmers nowadays, we have less farmers than we used to. I think it's less than 1% of the population are farmers. But if you think every single farmer, there are a lot of people working in the agricultural industry for that farmer. And I heard some statistic like there are 300 people working in the industry per every farmer. So if you have a farmer, you need an extension agent, you need somebody to sell that farmer fertilizer and different kinds of seed and a bunch of other different products, and people working in the government like the U.S. Department of Agriculture. So there are a lot of fields that are in agriculture that isn't necessarily doing production ag, but assisting with production agriculture.
Yeah, absolutely. It's all a really big interconnected system, and we sometimes don't really realize how many connections come from just like one single occupation. But yeah, thank you. But Kelly, if you don't mind, maybe you could share with our viewers just a little bit about what the North Florida Research and Education Center does and kind of what makes it unique.
Yeah, so we're located on 400 acres here in Suwannee County, and what makes us unique is that we have a lot of research projects that come through here. About $30 million worth of projects come through this facility, and we have corn, watermelon, peanuts, tomatoes. They can be hydroponic, sometimes they're field crops, and we do a lot of our work on water quality and quantity because that's a hot topic here in the state of Florida. So we do a lot of different things depending on exactly what you want to do, anywhere from food safety to water quality.
Yeah, and how many people roughly do you have working here?
We have just under 30 people working here.
Mm-hmm.
We have a very large farm crew. They do all of the work, so the researchers will tell our farm manager exactly what he wants to, what they would like to happen on the crops, and then our farm crew makes it happen. Otherwise, nothing would get done here probably.
The unsung heroes,
they
for sure.
really are.
No, absolutely. Well, thank you both so much. But I think now Jay is going to take us through a bit more detailed exploration, I guess you could say, into soil and soil health. So if we want to go ahead and move over here, we have actually a table that is set up to give us a soil demonstration.
So I'll move here first. Get the flip book. So I'm going to go through my soil science presentation, and like I said, I did my master's in soil science, so it's a topic that's very close to my heart. And we'll flip the first page here, and we're going to go over the different functions of soil. So soil, it provides habitat for plants, for crops to grow, but also for microbes. A lot of the organisms that grow in the soil are little microscopic organisms that you need a microscope to see. And if you ever get the chance to look at compost or soil under the microscope, I highly recommend it. There's so much going on in the soil, and you'll be amazed by how alive it is and how there are things running around, little small things like nematodes and other types of small microorganisms, and they're often eating each other and breaking down organic material, which I'll get to. So it's very exciting to look at soil under the microscope. Soils are also a source of nutrients. So if you think about nitrogen, phosphorus, potassium, some of the stuff that you see on fertilizer bags, that also exists in the soil. And there are micronutrients as well in the soil. So there are a lot of different nutrients that plants need to grow, and they exist in our soil. Soils also hold water. You'll be amazed by how long soils can hold water for, even when it hasn't rained for a long time. So that's a really important thing that soils do. And they also provide physical support for everything from plants to grow in to skyscrapers. And this is a soil that we dug up over in Bradford County. And you can see up on the top, there's kind of darker color there. And then you have a lighter color. And then you have a clay kind of orange color, kind of like the soil you might see up in Georgia when you go there. So up on top, the reason you see the darker color is because that's the organic material. Organic material is basically dead material that was once living. So decomposed plants, decomposed leaves, pine needles I see in there, decomposed blades of grass and roots. So that's all organic material. What organic means in science is made out of carbon. If you ever get the chance to take organic chemistry when you come to college, you might not like it because it's really hard, but it means made out of carbon. And all this living material, from plant residues to animals that decompose to manure, that's all made out of carbon that goes into the soil. So we'll go to the next slide. So this is a typical soil. You'll see that we have got about 45% mineral material. That's sand, silt, and clay, with sand being a larger particle, followed by silt being a smaller particle, and then clay being a very small particle. You have the organic material, and this is a typical diagram from a soil science textbook. They say that organic matter is about 5% in a typical soil. Well, Florida, we're a little bit different. We've got sandy soils, and we have very warm climate throughout the year compared to the rest of the country. So we're closer at a 1% organic material, and that's because sandy soils have more air in it, which provides oxygen for microbes to break organic materials down, and the warmer weather allows a longer period of time for microbes to break organic material down in our soils. You also have water and air in the soil, and that fluctuates based on whether it just rained or not. And we'll go to the next one. And this is just, I want to briefly touch on the different nutrients that soils provide. Everything from nitrogen, phosphorus, potassium, calcium, magnesium, sulfur. Those are all the macronutrients. And then you have the micronutrients as well. Plants need macronutrients in greater quantities than micronutrients, which is why they're called macro and micronutrients. And you see the nitrogen basically system here. And nitrogen's a really important nutrient when it comes to plants. It's probably the most important nutrient. So when you think about plant growth, for most plants, they really need nitrogen, and we'll talk a little bit about that today. Go on to the next one. So another component of soils is pH. Some of you may have taken the pH of your fish tank at home before. pH has to do with the concentration of hydrogen ions basically in the soil, and it ranges from a pH of 0 all the way to 14. And what the pH is in the soil will affect what kind of nutrients are available for the crop. So you may have the same amount of phosphorus in the soil, but it may change forms at lower pHs, which is a pH kind of lower than 7, also known as acidic pHs. Phosphorus may bind with iron or aluminum, and then at higher pHs, phosphorus may bind with calcium. So if you see with this diagram here where the line is fatter, basically you have more availability of that nutrient. So in areas where it gets really thin, there's less availability based on the pH. Go to the next one. And when we talk about soils, traditionally we've talked about the chemical aspect of soils, so pH and the amount of nutrients that are in our soils, but it's also important to think about the biological, what's in our soils, the microbes, the beneficial organisms that help plant growth, and also the physical component of the soil. Like I said, soils are really important for holding water for plants, and having organic material in our soils not only provides our plants nutrients, but it also provides soil that holds more water and is less likely to be compacted. We want a soil to act like a sponge. Plant roots can kind of make it through a soil that acts like a sponge, right? They can't make it through something that acts like a brick. And for every 1% increase in organic matter, that can result in up to 20,000 gallons of available water per acre. So it's really important for holding water in our soils to have more organic material. We'll go to the next one. And like you see, when you have a compacted soil, you have less space for water, air, and organic matter. So you don't want to have a compacted soil.
And just a quick question. So when you're thinking about the soils that are here, would this be more of an example of, do you see more compacted soil or undisturbed soil in the soil that you work with here on the farm?
You sometimes see compacted soils if you think of tractors and other, tillage equipment that passes over the ground. Sometimes you see a little bit of compaction at 12 inches, but here in Florida we have sandy soils mostly throughout the state, so our soils are a little bit less likely to be compacted than a clay soil,
right,
where you have the same type kind of equipment going through. We'll go to the next one. Another topic I want to touch on really quick is sand, silt, and clay. So sand, think about those as big particles in the soil, like basketballs. Silt is a smaller particle. It's much smaller than sand. You can think about, bouncy balls or something like that, or maybe golf balls. And then clay is really, really small. And at this scale, it's invisible. Now, some of us we can all see an individual particle of sand, more or less. Some of us could see an individual particle of silt, those who really eat their carrots. But when we get to clay, when you have a single particle of clay, you cannot see it because it's microscopic. Basically, for our eyes, you would need a microscope. So that's how small a particle's clays are. And this is a really important topic when you think about soils. And we'll go on to the next one. And one other thing I wanted to touch on is, all the animals and all the microorganisms that live in the soil, from bacteria to fungi to nematodes, which are like little microscopic worms that live in the soil. These are all the different things that live in the soil. Many of them feed on organic materials, and then some of them will feed on each other. So when you have a good, healthy soil, you have a good, diverse soil food web. So you don't have one pest species that gets out of control. Certain bacteria, certain fungi, certain nematodes can be problematic because they'll deteriorate plant health. They might be a plant disease, or they may feed on plant roots like the nematodes. So you need a good, diverse food web of animals to make sure that pests don't get out of control. we'll go to the next one. I think and yeah, just one more topic I wanted to focus on. Focusing on the physical, the chemical, and the biological components of soils helps us reach soil health. So that's a topic that I want to talk about today. I used to work in a lab that tested soils for soil health. It tested physical, chemical, and biological characteristics of the soil. So that's kind of what I'm talking about when I'm talking about soil health. Now we're going to move on back to a soil that I dug up today. And this was a soil that was here at the North Florida Research and Education Center, Suwannee Valley. And you can see the darker color on the top of the soil. Where I'm at up here is probably about the first 6 inches or so of the soil. And there's a darker color on top, and then it begins to fade a little bit. And you begin to have a lighter color. And basically what's happening on top here is this is where a lot of the organic material accumulates in the soil. This was dug out of a row crop field, so the crop residues that's been left behind, the grasses and the roots that have been left behind in the field. So that's kind of the darker material. And then as you go down the soil profile, you're beginning to see areas where rain water and irrigation water has passed through for millions of years, basically. And down here you see kind of a sandy material, but it's coated with a little bit of iron oxides. So it has a little bit of a color to it. Maybe there's a little bit of clay in there, but it's mostly sandy. And as you keep going down, I think we would eventually see a horizon of organic material down here where other stuff has accumulated, stuff that has passed through the soil and accumulated down here. And what I did to dig up the soil today is I used my soil auger. This is my soil auger, and I just kind of want to give you an idea of how I sample soils. I'll go down with this soil auger, see it here, and I'll take a sample at different depths. So I know everything from here to there will be 6 inches, from here to here will be 12 inches, and then I have it marked off where 24 inches are, and then where 36 inches are. And what's pretty cool about this is I could go pretty deep, because I can adjust this if I wanted to. Take this out. Oh, well, yeah, gotta take this one out actually. And I could keep going even if I got below here. So I'm not sure exactly how deep this will go, but it will go pretty deep. It'll go much taller than I am. And this is really useful for studying nitrates. You'll learn a little bit about nitrates today. I've done some studies where I'm collecting nitrates from different soils to find out where soil nitrate is at and if it's passing through the soil below the root zone. And yeah, so I think that's my my soil presentation. If there are any questions.
Well, I have a question actually right off the bat. Just thinking about our audience that we have here today, why should we care about soil health? Why is that important for all of us?
Well, I think it comes down to, soils are a natural resource, and we need them to be able to eat food. Do we all eat food here? I think we probably do, right?
Absolutely, we do.
So it's a really important natural resource for us to preserve so we can continue to grow food in the future. And, we might still be able to grow food on degraded soils, but not as well. We'll have lower yields and we'll face other issues. And when soils get really degraded or really eroded, or in the case of South Florida where we have a lot of soil subsidence of the organic soils down there, you might get to the point where you can't grow the same crops anymore. I guess we're going to move this way.
Well, thank you everyone for tuning in. We've got some questions. First from Allison. Jay, how did you decide that you wanted to work in soil science?
I took a class when I was in college. I think it was my junior year of college, and I was just very interested in it. It had a component of geology to it, and biology, chemistry, and kind of physical sciences as well. So I think I just liked how it touched on different topics.
Great, thank you. From Caleb Dean, what is the best thing we can do to help the soil and maintain a good, healthy soil?
So there are a few different things we can do. One thing is trying not to disturb the soil too much. When we disturb the soil with tillage or we dig up soil, that can degrade the amount of organic material that's in it over time. So keeping soils covered with vegetation like grass or trees, that's basically a good way to keep a soil healthy. And also when we do have to disturb soil, like for agriculture, adding organic materials back in. So those organic materials might be chicken manure, they might be other types of organic material that that are a byproduct of something that we use for other purposes like horse bedding or other byproducts.
Thank you, Jay. Allison would like to know, do farmers do soil samples on their own farm?
Yes, they do. Farmers will often, the farmers in my county will often have me go out there and take a soil sample for them. And sometimes they'll take a soil sample themselves, but it's really helpful for them for growing the crop. I think generally farmers don't always soil sample before they grow the crop, but they generally have an idea in the field that they're working in that, a soil sample within the last 5 years or so they know what they're doing.
Great. Laura would like to know, what type of soil, sand, silt, or clay, works best when growing vegetables, or does that not have a strong impact in plant growth?
It does, and so when we talk about different types of soil, there's often sand, silt, and clay in the same soil, but usually one texture is predominant. And silty soils are generally kind of a best of both worlds when it comes to growing vegetables. They erode very easily, but they're generally a good soil. But some vegetables that like to be well drained, a deep sandy soil like we have here in Live Oak is a good soil for growing vegetables.
Great, thank you, Jay. One last question. Do farmers have to add organic matter to soil to grow crops?
Sometimes they do, and if you're growing vegetables organically, you have to add organic materials back in to the soil because you don't have access to conventional fertilizers for the nutrients. But sometimes farmers will do a mix of both. They'll add organic materials back in and conventional fertilizers into the soil.
Awesome. Well, thank you so much, Jay. We really appreciate you letting us know so much about soil. I know for me personally, soil's not something that I really think about every single day, but it's such an important aspect to all of our lives and all of our food production. And so, yeah, it was really great to learn some more detailed information about it. But we're going to be doing a slight shift now, and so we're going to be hearing a video from Dr. Sudeep Sidhu. So he is one of the extension and researchers here at the North Florida Research and Education Center. He focuses on things like water quality management and also different nutrient management for certain cropping systems here in Florida. And so we're going to be hearing a bit more scientific language from Dr. Sidhu, since he's a very smart man, certainly smarter than me, and I have some trouble understanding certain things. So you're going to be hearing certain terms like nitrogen or nitrate leaching. And so luckily, we do have another expert with us here, Kelly, who can kind of explain both of these terms for us so that we can have more of an understanding going into the video.
Yeah, so nitrogen is just one of the many nutrients that plants need to uptake, just like we need to have calcium and different things like that. They need nitrogen in order to grow bigger and stronger. And the nitrate leaching or nitrogen leaching, it's basically just whatever was left over that the plant didn't take up, it went through the soil and went down into our water. So those are our two main terms that you need to know for this.
Awesome. Well, we're going to go to our video now, so keep those terms in mind as you watch this.
Hello everyone, I'm Dr. Sudeep Sidhu. I'm a regional specialized agent in agricultural water management, and I work here at North Florida Research and Education Center in Suwannee Valley. Most of my research is focused on water quality and water resources. Water quality at this point is one of the prominent issues in agriculture here in Suwannee Valley where we are, and as well as at least in the whole part, the northern part of Florida. So most of my research efforts are focused on water quality, which indirectly relates to nitrate leaching. So for those of you who are unaware of nitrate leaching, nitrogen is one of the major food components for plants. And not all the plants take nitrogen as nitrogen. So some of the plants take nitrogen as nitrates, and some of the plants take nitrogen or uptake nitrogen as ammonium. So, or ammonia in the ammonium form. So it's kind of like, you know, if you like chicken, for example, if you have fried chicken versus baked chicken. So, but most of the row crops that we have here in Florida, they uptake nitrogen in the form of nitrate. Now the question would be that why is nitrate important? It is because nitrate is very soluble in water. So every time there is a rainfall event or we irrigate our crops, every time water comes into contact with the nitrogen fertilizer, which now is in form of nitrate because that's how the plants uptake it, the nitrates get dissolved into water, and due to our deep sandy soils here in state of Florida, the water moves down or percolates down the soil profile very quickly, and with that water, all the remaining nitrates that are still in the soil and haven't been uptaken by the plants. So that's why when all those nitrates that are not utilized by the plants go below the root zone, because once the nitrates pass below the root zone, there is nothing stopping them because now the plants are not uptaking any nitrates. So those nitrates easily go to our water table. And then excess of nitrate concentration in our waters is causing the water quality issue. So the big question is that why do we even care about nitrogen moving down the soil profile? And we care for that because all that excess nitrogen that reaches our water, groundwater, that water ends up being in our springs, in our rivers, and that excess nitrogen is toxic. It is toxic to our sea animals. It's toxic even to humans at certain point if the concentration of nitrogen in those waters is higher than a particular level. That's why we care so much for nitrogen reaching down the soil profile, and we are working to come up with different ways to quantify how much nitrogen we are able to save from moving down the soil profile, and this project with the use of grain gauges is helping us improve our knowledge about it. So the next question in your mind would be, what is a lysimeter? There are different kinds of lysimeters. There are certain small lysimeters. They are called suction cup lysimeters. These are the big lysimeters called the drain gauge lysimeters. A lysimeter in itself is just a reservoir that is able to capture the moving water that's moving down your soil profile. An equipment that is able to capture that water is called a lysimeter in very simple terms. And based on what purpose you are using that lysimeter is for, you can either use a suction cup lysimeter, which is a small piece of equipment, or you can end up using the drain gauge, which provides us a lot of flexibility in terms of data collection.
All right, so just to kind of give a little bit of a recap after this, Kelly, could you tell us a little bit about why nitrates can negatively impact the water quality?
Yeah, so it's a trickle-down effect if you really think about it. So water moves through the soil profile into our aquifer. If there's too much nitrogen, that nitrogen can create algae in our springs and rivers. And that algae, it stops sunlight from going in, which means that our submerged aquatic vegetation is unable to grow, which means that manatees, turtles, and fish don't have anything to eat. And so if you've heard about the Indian River Lagoon that happened, it's in South Florida where we had a lot of manatees die. That's one of the reasons why, even though it's a more phosphorus-related issue. So it can be a pretty big problem.
Yeah, I think that describing it as a trickle-down effect is really a perfect way to say it, and it's definitely a bigger problem than we might realize on the surface.
Yeah.
Well, I'm going to move over to Marissa again, and we're going to take some questions from you all. And Kelly, you can bravely answer them.
Awesome.
Thank you so much, Maddie. So Sean would like to know, is it possible to retrieve the excess nitrogen from the water?
Ooh, that's a very good question. You know, there are a lot of different things that people are doing research on. There's this one person, and I'm going to get the terminology completely incorrect, but there's somebody that he has built these lysimeter type things under the ground that actually funnels the water into an area, into a lagoon that actually pulls those nitrates out before it gets pumped out. And then also on dairy farms, another way that they pull nitrates out of the water from any waste is that they just put it back over a corn, and the corn helps take that nitrogen out. And so there's some kind of innovative ways that you can do it, but it's not necessarily just a pump and filter it out and then dump it out again. So.
Thank you, Kelly. Okay, David would like to know, is it better to only put a little nitrogen at a time on the crops instead of all at once? Or how much should you put on at a time to keep it from flowing below the roots?
So it really depends on what kind of crop that you have. But yes, it is absolutely better to just put a little bit at a time. If we think about a corn plant, the UF-AEC recommended rate of nitrogen for corn is 260 pounds per acre. And so what we encourage farmers to do is that they end up putting out a starter fertilizer, but you have to pay attention to the weather, because in Florida we rain a lot. So you don't want to put nitrogen out and then have a leaching rain event because all your fertilizer is going away. So we would much rather you put out 30 pounds here, 30 pounds there, and band it directly by the row. That way it's directly accessible to the plant. That's not always the most realistic or the most economically feasible way to do it, but that is one way that we encourage to reduce how much nitrogen we're putting on our plants.
Great. Thank you, Kelly. Sophia would like to know, how do you guys plant your vegetation so that there is no nutrient depletion?
Oh, I mean, there's so many different ways that we can do it. The main thing is just managing your water and managing your nutrient application. It doesn't really matter necessarily how the plant is planted necessarily. We are starting to do some different things with corn and trying to do a more narrow row on a corn, but that means buying hundreds of thousands of dollars of new equipment to make that happen for a farmer. But really and truly, if you manage your water, your irrigation correctly, and manage putting out your nutrients correctly, then you should be able to really reduce how much you have leaching through the soil profile.
Absolutely. All right, one final question for you, Kelly. Caleb Dean would like to know, what is the biggest impact humans and farmers have had on the nitrogen cycle? Can you give a positive and a negative?
Ooh, positive. I do have to say that technology has really changed throughout the years. I've been in this position for 3 years, and things have definitely changed. And because of the pressure, the negative aspect is that there's a lot of chatter and a lot of pressure for farmers to make changes, and that can be very expensive. But because this research center has proven that these best management practices, or these advanced best management practices work, we're able to actually give some cost share money to our Florida farmers in order to make those changes. So there's a positive and a negative in that we can help. You know, we're able to move these things on a little bit further and hopefully a little bit faster so that we can reduce our impact. But farmers are actually doing a great job. We always have a few outliers, but in general, farmers are doing an amazing job managing their water and nutrients.
Awesome. Well, thank you so much, Kelly. Now we're going to go on and move on to one of my favorite parts of this virtual experience. We're going to be talking today more specifically about one of the crops that are grown right here at the North Florida Research and Education Center, peanuts. So all of you who maybe have some peanut allergies, today's your day to get up close and personal in a safe way so that we can learn about this awesome crop. So Jay, if you want to go ahead and take over.
Yeah, well, I want to talk about peanuts because I work with peanuts a lot. A lot of the farmers that I work with in Columbia County grow peanuts. It's probably our biggest crop. So we generally grow peanuts in North Florida for peanut butter production, but there are a lot of different uses for peanuts. One use is peanut butter production. Another use is peanut butter or peanut oil. If you've ever been into Five Guys, you'll see that a lot of their fries and their burgers are cooked in peanut oil, and it's a very tasty cooking oil. You also see peanuts, especially down south here in Florida, they'll be boiled. And other places like Texas Roadhouse, you'll have them roasted. And we all had Halloween this week, so I'm sure many of you had some chocolate-covered peanut bars. So another thing I want to touch on with peanuts is that they're such an important crop when we think about world hunger. So peanuts, a lot of world hunger that exists around the world exists in really rural areas that are hard to access. And peanut butter isn't something that you have to refrigerate, and it has lots of protein in it. So there are also peanut fortified pastes that you can kind of make a peanut butter out of, and those are commonly used in developed countries where people are starving. So peanuts save a lot of life, and they're a very important food crop. We'll go on to the next. So I want to touch on George Washington Carver. George Washington Carver was a very important peanut scientist. He was actually born into slavery in Missouri, and he went on to earn his master's degree at Iowa State University and become a professor and research, and I would even call him an extension, basically specialist at Tuskegee University in Alabama. And he would work with the farmers in Alabama, and he would work with the public, and he taught them a lot about peanuts. And he invented some uses for the peanuts as well. And this was really important at the time because we grew a lot of cotton in the South. And because we grew cotton year after year after year, pest pressure and disease pressure built up. So we needed a crop to grow in rotation with cotton. And peanuts ended up being a great crop for that. We specifically had the issue with the cotton boll weevil, and those were very bad pests for cotton. So growing peanuts definitely helped out southern agriculture quite a bit, and it was a great food crop to move into southern agriculture. And one thing that George Washington Carver is famous for is that he addressed Congress about the different uses for peanuts. And he only had like a certain amount of time to address Congress. I forget if it was 20 minutes or a half an hour, but the committee that was listening to him kept extending the amount of time because he had such interesting presentations, and they were so interested in the different uses for the peanut that he's discovered. So he kept on getting his time extended for his presentation, and he became a household name. We'll go on to the next one. So peanuts came originally from South America. They moved over to Africa and the Old World, and then they moved over to the United States. And that's why you see peanuts generally grown in the southern part of the United States. They're a warm climate crop. And we'll go on to the next one. And in the United States, they're grown, the largest producer is Georgia. Our neighbor is just north of here, probably less than an hour from here. They grow the most peanuts in the United States, followed some years by Florida, or some years by Alabama. Us and Alabama produce similar amounts of peanuts. And some other states you see that produce peanuts is, up the Atlantic coast all the way to Virginia, peanuts are produced, and then all the way over to Mississippi as well. So a very common crop in the southeast that's produced. But they're also produced in Texas, Oklahoma, and New Mexico as well. And this is a peanut plant. So you see that peanuts flower above the ground, and then when they're done flowering, a peg will come out, and it'll kind of grow down into the ground and grow the peanut pods that you're used to seeing. And what's so interesting about peanuts is that they're really hard to determine when to harvest peanuts, because peanuts, they need to be, you can't see them because they all grow underneath the ground. So it's not like walking through an orange orchard where you can see when all your oranges are ready. Peanuts grow underneath the ground, so you have to go out and dig up the plants. The other thing about peanuts is that they're an indeterminate crop, and what that means is that different peanut pods, even on the same plant, will mature at different times. So we have a picture here. You see some of the bigger peanut pods that look like they're more mature, and you see that smaller peanut pod right there. So depending, even on the same plant, peanuts will mature at different times. So you can never harvest peanuts at a time when all of them are mature. It's not like corn or wheat, which mature evenly throughout the field. With peanuts, they mature at different times, even on the same plant. So you can only harvest peanuts when most of them are mature. And that's one thing that I do at the end of the peanut season in late August and early September, is I consult with my growers, and I use a method called pod blasting, which we'll discuss in a minute, to help determine peanut maturity. Go on to the next one. And the last thing I want to touch on is just how peanuts are harvested. This is a digger that was here at the North Florida Research and Education Center, Suwannee Valley. You see they're digging up the peanut plants, and you can see the peanut pods are out on the surface of the soil, and they'll lay them out in dry weather for about 3 days or so. and they'll dry out, and then after they dry out, they'll come through with a combine and they'll separate the peanut pods from the vine, and they'll harvest the peanuts and bring them to the local buying point and sell them. So now I'm going to walk you through the process of how we pod blast peanuts to determine maturity, which is just an important method that we use to determine when to dig peanuts. And it's really important for my local growers because they need to know when to harvest their peanuts when they weigh the most and that they're mature, so that they make the best yield that they can. Yeah. So the first thing that I do, and I want to show you what a peanut looks like. This is a typical peanut. It looks pretty similar to a roasted peanut you might see at Texas Roadhouse or at a baseball game. And what we're going to do is I'm going to take a pressure washer to them and get rid of the outer shell so that we can see the color underneath that outer shell. And the darker that color is, that indicates maturity. So I'm going to go take my pressure washer now. That many of the peanuts, we begin to blast out that outer shell. You can still see some of the outer shell. I didn't do too good of a job, but you can see the color underneath. You see that dark color. Let's see if we can find one that's lighter. This one has more of a yellow color. This is a little bit of brown on this side, but you see that this one has a darker color underneath, and this one has a lighter color underneath. So we want most of our peanuts, maybe 70% or more, to look like this darker color underneath that outer shell. So now what I'll do is I'll show you some peanuts that we pod blasted earlier. It takes a while with the pressure washer to get that outer shell off, so I'll show you what I did over here. And I used my peanut maturity board here, and I laid out the peanuts based on their color. So you can see I have a really brown one here that's fairly mature. And you can see I also have kind of yellow looking ones. That one's not quite mature yet, but it's beginning to develop a little bit of color, a little bit more than one of the whiter ones or the smaller ones here. So this is how I lay them out, and I'll tell the farmers basically how much longer I think they need to leave their crop before they dig it and harvest it so that they can make the best yield that they can.
Awesome, Jay. Well, thank you so much for that. I think right now we're going to go ahead and switch over and hear some questions from our viewers.
Great.
Thank you so much, Maddie. Okay, so David would like to know, Jay, are there any brands of peanut butter that have peanuts that were grown in Florida?
Well, I think probably a lot of the peanut butter brands probably have some peanuts from Florida. I've had certain ones from the local peanut federation that I know are local peanuts, but I would guess that some of those peanut butter jars that you get have some peanuts from Florida in them. Oh, M&Ms do? I'm being told that M&Ms often do.
Thank you, Jay. Okay, Sean would like to know, is there a specific reason that Louisiana does not grow peanuts despite being in the same area as the other peanut producing states? Is Louisiana's soil different?
My guess would be that there's a little bit of peanuts grown in Louisiana. Louisiana has a lot of different crops, from sugarcane to other stuff that's grown along the Mississippi River there. I think some rice is produced in Louisiana as well. So it has a lot of different crops that are grown there. My guess is that there's a little bit of peanut production, but it wasn't major enough to make that, that map that I had.
Great, thank you, Jay. Laura would like to know, why do we want the peanuts to be more mature? Does it make a difference in how they taste?
It's not necessarily a difference in how they taste, but if the more mature the peanuts are, if more of them are in this kind of range, that means that they will weigh more. And the farmer is paid on how much the peanuts weigh. That's his yield. So the more that they weigh, the greater yield he gets and the more money he makes. And that's important because a lot of money goes into a peanut field, from the gypsum that you have to put down to some of the fungicides that you have to put down. So that's really important for him to make money.
Great, thank you, Jay. One more question, and then we can wrap it up for the day. David would like to know, do they blast all the peanuts that they harvest, or is it just a sample to see if they are ready? Also, can you open a yellow one and a dark one and see the difference inside?
Yeah, so they'll generally just take a sample. So I'll go to a peanut field and I'll dig up 4 or 5 peanuts plants that are, and I'll try to take a plant and not lose any peanut pods at the bottom when I dig it up, and I will take every single peanut pod off that plant and pod blast them, so it's a representative sample. They won't pod blast every single peanut that they have because that would be a lot of peanuts. That would be really difficult. But we can actually take a yellow one. Some of these yellow ones, these are kind of old peanuts, but they're the less mature ones. And some of the difference, some of them are kind of falling apart already. You'll see the difference inside. Still a little bit of color difference inside. And some of the black ones, you'll begin to see the veins inside. More so. So you see kind of the oil stains in this one. When they begin to develop oil stains on the inside, they're very mature peanuts.
Awesome. Well, thank you, Jay. So if you actually want to come on over here, I would just first like to thank you both for taking the time out of your day to really bring us through all of this and to give us such awesome information. And I would like to also thank all of you who are at home probably right now watching this. We really appreciate you all also taking the time out of your day. We hope that you learned something. And I would be remiss if I did not go ahead and thank our awesome streaming science crew. We are a group of University of Florida graduate and undergraduate students who have been working all semester to bring you this electronic field trip experience. And so if we want to go ahead and move over to you all, I'll introduce you to the rest of our crew. So this is Kayla, who is our head director. She is the one who has been in control pretty much of this entire thing, changing our screens to control what you all are seeing and to give you this really great experience. We have Marissa here, who is who you know and has been running our question and answer sessions. This is Caroline and Dr. Luizzo, who have been running us up and down this entire time. No, Dr. Luizzo is the person actually who has really been a big spearhead in getting these electronic and virtual field trips up and running, and Caroline has been our fearless TA who has been helping us through this process, and so we couldn't have done it without the two of you. And then finally, we have our camera crew. So this is Annabelle here, who has been working one of the cameras. As you can see, she's holding one of the iPads. And so we do all of these using iPads in a mobile communications kit. So we can really go anywhere as long as we have some internet connection and bring these experiences to all of you. And then finally, we have Maggie here, who has been also working one of our iPads and doing a fantastic job. And so if you've enjoyed this experience and you're interested in hearing more about different scientific topics and really just broadening your knowledge base, please feel free to go and tune into Streaming Science. We have a website. We also have different videos, electronic field trips, and also podcasts and many other things that we do in order to give you an interactive and immersive experience and to really just learn about the cool things that are going on around you. So thank you all again so much for your really awesome questions and for your attention, and we really hope that you enjoy